Hi, this is assignment number 3, and we're going to be solving the differential equation y double prime minus y equals e to the x using variation of parameters. First, what we want to do is find the solution to the homogeneous system. So we can rewrite this as y prime minus y equals 0. And from here, we can find our characteristic equation and its roots. So this will be r squared minus 1 equals 0, which gives us that r is, which we can rewrite r plus 1, r minus 1. So we have that our roots are r equals -1 and r equals 1. And so now with this, we can write our solution to this yc equals c1 e to the negative x, and then, or I'll do c to the x, and then plus c2 e to the negative x. And our two solutions will be y1 equals e to the x and y2 equals e to the negative x, as we can see. So from here, what we want to do is go into calculating the Wronskian given these two formulas. So this will be for us trying to solve the non-homogeneous problem. So with that, we know that in this, since this makes it homogeneous, this makes it non-homogeneous, this e to the, so our non-homogeneous term is e to the x, and the Wronskian, like I was saying earlier, is going to be calculated from these two functions, solutions that we have here. So the Wronskian is given by y1 times y2 prime minus y1 prime times y2. So given these, y1 is just e to the x, y2 prime is negative e to the negative x, minus y1 times e to the negative x. So that's our Wronskian. And then we can simplify this out, because e to the x times e to the negative x is just equal to 1. Because this is just e to the x minus x, which is e to the 0, so which is equal to 1. And then e to the x times negative e to the negative x is equal to -1. So this whole thing is equal to -1 minus 1, which is equal to -2. So that's what our Wronskian is. So then from there, we want to find parameters u1 and u2 using the formula given, using the integral formula given by them. So u1 is given by the integral of negative y2 times f of x over the Wronskian and dx, and then u2 is given by integral of y1 times f over the Wronskian dx. So we can calculate u1 first, and so plugging everything in, we get the integral of negative e to the negative x. Yeah. Negative e to the negative x times e to the x all over -2 dx. And then the e to the negative x and the e to the x cancel out to 1. So this leaves us with the integral of 1/2 dx. And so u1 is equal to 1/2 x. And then now we want to solve for u2. I'm just going to bring this down. Solving for u2, substitute everything in, so we get integral of e to the x times y1 e to the x and all over w. And then the integral of this, which is -2, and then the integral of this, e to the x times e to the x is e to the 2x. So the integral of this is just -1/2 integral of e to the 2x dx. And so our u2 is equal to 1/2 e to the 2x, all multiplied by -1/2, because the integral of e to the 2x again is 1/2 e to the 2x. You just bring out, you're just trying to cancel out the 2 in the front. So then this will just be -1/4 e to the 2x, this whole u. So now we have solved for both u1 and u2. So from here, we just want to put it into the formula that's given for the particular non-homogeneous equation, which is yp equal to u1 times y1 plus u2 times y2. So we just plug everything in, which is u1 is 1/2 x e to the x plus -1/4 e times e to the -x. And we can simplify this to just be 1/2 x. So for our full general solution, we can rewrite it as this plus what we just solved for here, this, which is c1 e to the x plus c2 e to the -x plus 1/2 x e to the x minus 1/4 e to the x. So notice that the -1/4 is just a constant multiple of e to the x, which is already part of our solution here. Here, the c1 e to the x. Because c1 is just an arbitrary constant, it can just observe this term as well. So therefore, we can still simplify this to just be y equals c1 e to the x plus c2 e to the -x plus 1/2 x e to the x. So I think both of these are valid here. Thank you.